guys. So, welcome to this course, which is called Mechanics of Solid 2. These are the contents which we are going to cover in this course. The content includes stresses and beams, then following that to combined stresses, failure theories, and theory of columns. In the stresses in beams, this is something which you have already covered in your Mechanics of Solid 1, where we were introduced to flexure theory, okay, or what is called engineer's beam theory. And in Mechanics of Solid 2, we will go to a bit more advanced level. So, in other words, we will study shear centers, unsymmetrical bending. So the main theory is the same, and I will reintroduce that to you again in this class, because the main basis, the main crux of that theory is the same. Okay, so, and you need to understand that you need to refresh your memories about the flexure theory, because that becomes basis for shear center and unsymmetrical bendings. Okay. Then after that we will do combined stresses. In combined stresses, we will discuss how various combination of forces act on structure and how does the structure behave. Okay, so in other words, we have combined structure subject to combined loading, for example, like axial shear, axial torsion, or something like that, and then we will study the behavior of the structures. Okay, mostly we will be concerned with beams, so we are not going to go to more complex structures such as frames. We will be focused only on the beams. So in the combined stresses, first of all, we will do axial force and the flexure force acting together on a structure, and we will study its behavior. Then after that, we will do turn of a section. If you have a compression in a structure where a structure which is subject to compression load, where should you apply that load in such a way that doesn't cause any bending? Okay, so we will try to find out that location. Then after that, we will do the stresses at a point. So, for example, if you have a structure subject to some loading, you will have some stresses developing in a structure. Okay, and at each and every point there is some stress. Okay, so how can you find out stress at a certain point in a structure, and then you find out the maximum stress overall in a structure? So that is so that will be covered in the combined stresses, and then we can have following stresses we will also discuss strains, because stress always produces strains. So it's the same thing. We will apply the Hooke's law and find out our strains in a structure. After that, we will do failure theories, different type of failure theories. What is a failure? I mean, if you have a structure which is subject to some loading, it can fail in different ways. Like, for example, the structure might collapse. You might see the structure just coming down to the ground. Okay, that is one type of failure. You can have a structure which is hanging. It deflects significantly. Okay, that's another type of failure. So how do you determine the failure stresses and failure strains? That we will discuss in the failure theories part. And finally, we will have a quick look at columns. Okay, what are columns? Columns are axially loaded members. They are subjected to axial load, and sometimes, so again, the knowledge of combined stresses will be revoked here again, and it will be and we will discuss how axial load and flexure stresses, flexure loads, they constitute the behavior of columns. Okay, so that is something which we will do. Now, we will start off today with stresses in beams. So this is the same thing which you have done in your MOSII 1. Okay, so simple flexure formula. How is that derived? And then from there onwards, how do we get into more complex topics such as shear center and unsymmetrical bending. So that is what we are gonna start with. Okay, so do you have any question? Any question? So let us So we start off with stresses in beams, and the first thing we have is assumptions. The first assumption, which is a very common assumption in most of your undergraduate course of mechanics, and that is plane section remain plane.